Hello everyone. The next topic in AP Calculus course is inverse function. So from the very crude sense of the function, we understand that it is basically a machine. A function is a machine in which you give an input and you obtain a certain output depending upon the definition of the function, right? So if this is, I can write this function like this, that there is a machine f in which you give an input. We normally denote the input by x, and this machine will give you a certain output depending upon, as I said, its definition, and we write that output either by another variable y, or we can use another notation which is just the fx. Okay, so this is your machine depending, right? And we are not going into the details of that it has to be, not all the relations between input and output are called functions. There is a unique output, and we are not going into that. Okay, so we are just understanding for the sake of understanding of the inverse function. Okay, so this is f, input x, output is fx. Now if there exists a function denoted by, let us say, g, there is another machine, you consider another machine as g, whose definition is of course different from this f, and what you do is you put this output of the function fx as the input to this machine g. So what this g machine will give you as an output, right? This output is denoted by the composition function g of fx, right? If the g function is gx, input is x, it gives you an output as gx. Normally we denote any function by considering the variable as x, but here the input to the function machine g is fx, so we denote the composition g of fx as the output of function g, right? And if in some special cases, in certain cases, this g is defined in certain way such that this composition gives you the output as x. So what you will notice here is that whatever was the input, initial input x, which was the input to the function machine f, and after composition of this fx with g, you again obtain the original input as x, right? So this type of composition, if this exists, then we say that this function g is the inverse of f. This function g, we call this as the inverse of fx. Mathematically, how we will write this is that since g was the final output, the second function, and to this we give an input fx, and if this gives you an x, we call g as inverse function of f, right? And this x, if I am denoting this x, that means this x should belong to the domain of f. This is the domain, should belong to the domain of f, because originally x was the domain of f, right? If this x somehow lies outside the domain of fx, inverse function will not be defined, because this fx won't be defined. In order to define this whole composition, first this fx has to be defined, and if fx has to be defined, then x should lie within the domain of the function f, right? And similarly, we can also give another composition of function as that if g becomes the input of f written as fgx, then again it will give you the input as x. Now this x is different from this x. This x belongs to f, but this x will lie within the domain of, this time, the function g, right? As it clearly says that x first goes to g, and then this gx is going as an input to f to give as the output fgx, which in some cases, if it is giving you x, then we can say that f is the inverse of g. Okay, so what you are noticing here is that whatever was the input of the function, whatever was the input of the original function f, this becomes the output of the inverse function g. Okay, and whatever was the output of the original function f, that becomes the input to this inverse function g. So basically input becomes output and output becomes input in case of inverse functions, right? Please keep this in mind. This is very important because these two concepts, not two, basically it's a single one concept, that when input becomes output and output becomes input, this we will use to find out the expression of inverse functions, right? We will come to that in a moment, but before that let us see how we write the notation of inverse function, right? Because not all g function will be regarded as a inverse of f. There must be some inverse function notation associated with the function fx, right? So if f is the function, if fx is the function, then its inverse function is denoted by f inverse. I am not pronouncing it as f raised to power minus 1, but it is written as minus 1, right? This is not the index of f, right? So this is the notation of f. With, for now, we can write this f raised to power minus 1 f of x. So basically this is the inverse function, and please keep this in mind that this f inverse x is not equal to 1 over fx. This is the difference between the index and just the notation of inverse. Okay, this is not f raised to power minus x, or you can also write this as sine, or not sine, fx whole raised to power minus 1. This is not equal to f x raised to power minus 1. Okay, so this is very important. It is just a notation. Okay, inverse function are written as f inverse, and if there is an inverse function of function g, we will write this as g inverse. If there is a function h, we will write as h inverse, meaning h raised to power minus 1x. Okay, so this is about the notation. Now let us come to the method of finding out the expression for fx, right? But before that, there is one condition that needs to be satisfied for any function to have an inverse. What I mean by this is that consider one mapping diagram. This is set A, in which there are certain inputs, let us say x1, x2 and xn, and there is an output set B, whose elements are, let us say, y1, y2, y3 and so on till yn. Okay, now some inputs are associated, let us say like this, that x1 is associated to y1, x2 is associated to y2, and likewise let us say x2 xn is also mapped to y2. Okay, now once we understood that when input becomes output and output becomes input, in map diagram we can say that if this is a forward mapping I am saying that from A to B, right, from A to B, this f is defined from A to B, right? So this function is f. This mapping from A to B is for the function f. Now for the case of reverse mapping, if I am saying that for inverse function output becomes input and input becomes output, meaning that for inverse function mapping will be from B to A, right? So I need to write this as f inverse such that from B to A you should read in this direction. Okay, for now you should read in this direction because I need to match the mapping diagram. Okay, inverse function will be defined from B to A, right? So if I use another color to denote the mapping of the inverse function, that will be from y1 to x1 like this, or y2 to x2 like this. Okay, but in this particular Venn diagram, not Venn diagram, in this particular mapping diagram, you can see that this element y2 is mapped to two outputs x2 and xn. I am talking about the reverse mapping. Okay, I'm again repeating that this particular output y2, this output y2, for the case of inverse function, this y2 is mapped to x2 also and to xn also. Okay, just concentrate on this green mapping from B to A, right? And as we know that if we are calling an inverse function, it should also satisfy the definition of the function. And what is the definition of the function? That for a particular input, there cannot be more than one output, right? But in case of this mapping, we can see that for the input y, there are two outputs x2 and xn. So this is not satisfying, or this is against the definition of the function. So in this mapping, we cannot call f inverse to be a function. Meaning is f inverse does not exist for the function f. And what is the reason behind this one-to-many mapping? One-to-many, I'm calling, again I'm repeating this, in the context of f inverse function, you consider b as the input and a as the output like this. So this is one-to-many, and reason being that original function from a to b was many to one. Okay, so here is the case, or here is the final conclusion, that if the function is many to one, if your function f is many to one, then its reverse mapping will be one to many, which is not allowed. So what is the condition for any function to have its inverse is this. So let us draw another mapping diagram, that let us say inputs x1, x2 and so on till xn, and we have the output as y1, y2 and so on till yn, right? And all the elements of f are mapped with 1 to 1. So mapping of f should be 1 to 1. So that is its inverse mapping, its reverse mapping should also be 1 to 1. Otherwise, as we know that for a function many to one mapping is allowed, right? As you can see from this diagram, diagram number A, in this diagram you can see that this f is satisfied by the condition that many to one is allowed for function, right? But if, as far as its inverse is concerned, that inverse function will result in one to one, one to many, right? So its inverse does not exist, right? Fx, it exists because it is many to one, it is allowed, but its inverse does not exist, right? So for any function to have its inverse is that there is only one condition remains, that the function f should be 1 to 1. Then only you can do the reverse mapping, right? Which again will result in 1 to 1 only. So we can say that this f and its inverse, they both are inverse of each other, right? So this is very one important condition, and for this there is something which is called horizontal line test. Right? For any function to be called as a function, we had the vertical line test. You please remember that. Okay, if this is the function, not this one, sorry. Let us say if this is a type of function and you draw a vertical line, and if intersects at more than 1 point, although this is not the dollar sign, if it intersects at more than 1 point, we say that this mapping is not to be called as a function because it is one to many. Similarly, for the reverse function, for the inverse function, there is something which is called horizontal line test. Now you consider this diagram. Let us consider a simple, a very basic curve, which is the parabola y is equal to x squared. This is a function, many one function, but it is a many one function, and for any many one function, its inverse does not exist, right? So we say that in order to perform the test, if we do a horizontal line test, if the horizontal line intersects at more than 1 point, it is a many to one function, and hence its inverse does not exist. Now for any particular function, if we need to find out whether its inverse exists or not, right? Meaning if you need to prove that whether a function is a one to one or not, so one method of finding out that thing is you draw the graph, you sketch the graph and perform the horizontal line test. So horizontal line test is basically used to perform to perform whether the inverse exists or not, or to prove whether function is one to one or not. Fine. So y is equal to x square, its inverse does not exist, right? Now what do we know? What do we do to find out the inverse? Okay, there is something which is called restricting the domain. Restricting the domain of fx. Restricting the domain of fx means that we cut the domain of the original function fx in such a way that we pick 2 points between which the function is 1 to 1. Okay, as you can see from y is equal to x square, that from this point, from the origin, if we take only the right hand portion of the graph, this black portion of the graph, if we take, okay, we can see, meaning if I plot this on another graph like this, right, if we take for x greater than 0, if we restrict the domain of the function f that only positive values of x are allowed, then we can see that the function is 1 to 1 because it passes the horizontal line test. It only intersects at only single point. So now if we restrict the domain of y is equal to x square to the positive x values, then its inverse exists because now the function is 1 to 1. Okay, and we will again revisit this topic, restricting the domain of fx, especially in case of trigonometric function, because trigonometric functions all are periodic functions. Periodic function meaning if you draw the horizontal line test of any trigonometric function, it will definitely pass through more than 1 point. So all the trigonometric functions, they fail the horizontal line test. So in those cases, we need to restrict the domain of trigonometric functions in order to find out their or define their inverse function. As we know that there are inverse function of trigonometric function written as sine inverse, cos inverse, tan inverse, and so on. But what is the math behind the domain of those functions? This we will see in detail in the next class. So for now, I need to give the idea of restricting the domain of fx. Fine. Alright, now let us come to the algebraic method of finding out the inverse function. Right, so let us say we take simple example of y is equal to x square. Right, so it says the step 1 is basically making x as the subject. Making x as the subject, and then step 2, replace y with x, and since we have made x as a subject, and replace x with f inverse. So whatever expression you obtain by making x as the subject, that expression is the inverse function of the original function fx, right? And we have a habit of writing function with the independent variable as x, so that's why we replace y as x and then x we write as inverse function of x. Okay, so this is the basic method of finding out the inverse. And why this method gives you inverse? Answer is very simple. In the starting of the introduction of inverse function, we have learned this, that output becomes input and input becomes output. And what was the input? X is the input, so this time x becomes the output. That's why we have made x as the subject, right? And y was the output, that becomes the input. That's why we have replaced y with x. Okay, so this gives the inverse function. So for this, if I make x as the subject, it gives you x is equal to square root of y, and always remember there is always a plus minus sign if the equation is x square equal to something. Okay, now from the graph also, as we can see that if the function was many to 1, this y is equal to x square is a many to 1 function, right? So we have not restricted the domain till now. So this question was incomplete. I should mention x is greater than 0. Now I have restricted the domain. Now you can find out its inverse. Otherwise, as you can see from this expression, x equal to plus minus root y, meaning for a particular value of y, you get two values of x, one plus and one minus. Let us say y is equal to 4, so x you will get as plus 2 and minus 2. So this is one many. Okay, for one input you are getting multiple outputs, so this is not allowed. Okay, so if I have restricted the domain to positive x, so I will remove this negative y, because it says x is positive. So whatever x you will get, that should be positive. As simple as that. This x and this x, these two x are same, but here this x gives you the output of the inverse function, okay, which is positive, and that should match the domain of the function. That's why domain of f is the range of f inverse, and similarly range of f becomes the domain of f inverse. So here domain of f was x, which is positive. That domain becomes the range of x, which is positive, or which should be positive. Fine. And similarly, if x is positive, range of y or range of fx is positive. So here that becomes a domain, and as we can see, square root of y, meaning this y has to be positive. Otherwise, negative square root is not possible. Right? So see how beautiful maths is. Right? It combines all the concepts, whether you can, alright, you can study maths using any concept, but those concepts will always remain true. Okay, there are no if and but in maths. Okay, fine. So now the second step, this was the first step, that we have made x as the subject. Now replace this x with, so this is basically your inverse function, which is root of x. Okay, let us take another example. Find the inverse for y is equal to, let us say, 3 plus x over 2 minus x. Okay, so what we do is we interchange x and y, or do not interchange x and y initially. We first make x as the subject. So we cross multiply this, so 2y minus xy is equal to 3 plus x. Making x as a subject, it gives me 1 plus y is equal to 2y minus 3. So x is 2y minus 3 over 1 plus y. Right? And replacing, x with f inverse. So this is your f inverse x, and this is 2x minus 3 over 1 plus x. This is your inverse function. Okay, fine. Right, now there is one more thing that we need to understand is the graph of inverse function. Graph of inverse function says, meaning how you can sketch the graph of inverse function from the function fx. Okay, you just visualize this. Suppose we take the same example, y is equal to x square, by restricting the domain of x. So this is y and this is x. Now what we have done algebraically is, when, as we know, that output becomes input and input becomes output, meaning this x becomes the output axis and this y becomes the input axis. When we do this, what basically means is that it is just the reflection of this straight line, of this graph along some straight line. What I mean by this is, let us take, in order to understand interchanging x and y, what is the graphical interpretation of interchanging any coordinate? And this is a proven fact. You can also prove this, that if there is a straight line, y is equal to x, and there is a triangle like this. This coordinate is, let us say, 2, 0. This is 3, 0. and this is 2 comma 1. Now the point is, if I take the reflection of this triangle, this point is A, this is B, and this is C. If I take the reflection of this triangle ABC in the line y is equal to x, what is the effect of this? This 2 comma 1, the effect, that is a proven fact. You can also prove that you consider any point x comma y or alpha comma beta, and you take the reflection of that point in y is equal to x. You will observe that coordinates interchange. This 2 comma 1 will become 1 comma 2. This point will be 1 comma 2. This 2 comma 0 will be 0 comma 2, like this, and 3 comma 0 will be 0 comma 3. So 0 comma 3 will be here. So I get triangle, which you can see from the graph also that yes, it is actually the mirror image of the triangle ABC. This is A dash, this is B dash, and this is C dash. Clearly, it is a mirror image of triangle ABC. And how I can draw this? I know already that if I take the reflection of any point along y is equal to x, the coordinates interchange, meaning the coordinates of point A 2 comma 1, that becomes 1 comma 2, and coordinates of C 3 comma 0 becomes 0 comma 3, and so on. Right? You can prove this as your homework, or just a sake of practice. You take any point alpha comma beta and try to find out its mirror image in the line y is equal to x. Right? It's a very simple task. In IGCSE also and AS level also you have done this in coordinate geometry. That becomes beta comma alpha. Okay. Now knowing this fact, and I knew already that in order to find out the inverse function, I interchange the variables. Y becomes x and x becomes y. So basically the graph of any function, graph of the inverse function of the given function, right, will be the mirror image of the given function. Right? If fx is a function, you draw the graph of fx and you take the mirror image of that along the line y is equal to x. That mirror image will be the graph of inverse function. And how we have arrived this? It is just basically that simple fact that output becomes input and input becomes output. Same thing algebraically, that comes in terms of variable, and graphically that comes in terms of coordinates. Right? It's beautiful. So if there is a graph y is equal to x square, okay, only for positive x, and there is a line, let us say y is equal to x, always you need to draw y is equal to x line, and we need to obtain the inverse function. So what you do is you take just the mirror image of this. So this is something, a mirror image of x square. And if we have some basic knowledge of inverse function, and we have already find out the inverse function of x square denoted by root x, and this basically is the graph of root x, right, which is obtained from taking the reflection of y is equal to x square along the line y is equal to x. Okay, so let us consider a couple of questions based on the inverse function. It says that show that fx equal to x minus 2 upon x plus 3 is invertible, and we need to find its inverse. Right? First we need to prove that it is invertible or not. Again, there are various ways to solve this, but we have not come to other ways of finding out whether the function is one-to-one or not. Using differentiation also, we can prove the function is either increasing or decreasing. Using monotonicity, we can prove the function is 1-1 or not, but we have not covered that yet. So we will just use the graphical method. Okay. So let us draw a rough sketch of the graph. Drawing the graph for this function is also a complicated thing because asymptotes are involved. right? So as you can see here that x is equal to minus 3 is not allowed, so x equal to minus 3 will be one asymptote of the graph, right? Here the graph won't touch. Let us find out the zeros of the graph, where the graph will intersect the x-axis by putting y is equal to 0. So here comes the point 2 comma 0. The graph will cross 2 comma 0, and what is the y-intercept? Y-intercept is coming out to be minus 2 by 3 by putting x equal to 0, right? So this is minus 2 by 3, right? Now there is one horizontal asymptote also. There are two ways to find out the horizontal asymptotes. If in the numerator degree of the variable and the degree of the variable in the denominator they are same, by putting and finding out the limit of this, since we have not covered again the limit concept. So what you do is you first find out the expression of inverse function by interchanging x and y, and from there we will try to draw a horizontal asymptote also, right? So let us do this. So write down y is equal to x minus 2 over x plus 3 by interchanging x and y. So xy plus 3y is equal to x minus 2. Making x as the subject, it gives me 1 minus y is equal to 3y plus 2. That means f inverse x, I should write in x only. So x is equal to 3y plus 2 over 1 minus y. Now you can see from this that in inverse function, or basically in this y, this is not the inverse function yet because we have not interchanged the variable yet, right? We have just make x as the subject. So writing the function in this form or in this form, these two forms are same. We have not changed the variable yet. We have just make some other variable as a subject. So making the variable as a subject does not change the definition of the function, right? So this x and this y are original x and y, right? So you can see from here that y is equal to 1 is not allowed, meaning output cannot be equal to 1. Output cannot be equal to 1 because in that case x won't be defined or x becomes infinite. So learning this in reverse direction, that when x becomes infinite either in negative direction or in the positive direction, y becomes 1. So clearly y is equal to 1 is the horizontal asymptote. Fine. So the graph is something like this. It will approach to y is equal to 1 from minus 3, x greater than minus 3, and it will grow like this. And for less than minus 3, it will approach to 1 also, but in the positive sense, means the value is greater than 1 or 5. Okay, so this is the graph, basic sketch of the given function, and now using the horizontal line test, we can clearly see that the function is invertible. This is 1 to 1. There is one horizontal line which is y is equal to 1, which is not lying in the domain of the inverse function, or you can say that the range of the function y is not equal to 1. Y is not becoming 1. 1 is not in the range of y. Okay, so this line is not in the range, meaning except this line, the function is 1 to 1. Hence, we are in a position to say that yes, the function is invertible, and in front of this we have the expression also. So f inverse x, you can replace x with y as 3x plus 2 over 1 minus x. Okay, this is inverse function. Now it also says that to find out the domain of fx, as you can see clearly that for domain of fx is all real numbers except minus 3, that x cannot be equal to minus 3. From graph also we can see, and from this expression also we can see denominator should not be equal to minus 3, and this domain becomes the range of the inverse function, right? So range of f inverse x and domain of f inverse x is this only. This is the A part, and for B part, domain of f inverse meaning range of fx. As we can see from the graph that range of fx is equal to all real numbers except 1. And clearly it is giving you the domain of inverse function, that x cannot be equal to 1. Okay, so that's how input of function and output of the function are related to output and input respectively of inverse function. Let us do one more question on finding out the inverse of this. So we have been given y is equal to 4th root of 2x minus 7. Making x of the subject, how we can make this? Just pause the video and try to do on your own. So what we do is we raise the power to 4. First writing this as raised to power 1 by 4, and now I take the 4th power of the equation on both the sides. It becomes y raised to power 4 is equal to 2x minus 7. So x gives me y raised to power 4 plus 7 over 2, and this is in fact your inverse function. This is your answer. Okay, so that's it. This has become a long video, but since we are doing the syllabus in detail, so videos will be along a bit. Thank you so much for watching this. Please like and comment if you need any help in AP course or any IGCSE AS A-level syllabus, right? Please subscribe to the channel and see you soon. Thank you so much.